Collisions. During a collision, an object experiences a force for a specific amount of time, an impulse that results in a change in momentum. This means the object will either speed up, slow down, or change direction. The size of the force controls the amount of damage there is. The impulse causes and is equal to the change in momentum. The larger the change in momentum, the greater the amount of damage. Force, and therefore damage, is reduced by increasing the amount of time over which a collision occurs. Seatbelts stretch slightly to increase the amount of time the person is in contact with them, decreasing the forces acting on the chest. Crumple zones also increase the amount of time over which the collision takes place by deforming plastically on impact. This causes the car to take longer to stop and decreases the force on the passengers. The area of a force time graph is impulse. Conservation of linear momentum. The total momentum of a system remains constant provided that no external forces are acting. Newton's second law states that an object's acceleration depends on its mass and the force applied. Newton's third law tells us that the force experienced by object A is equal and opposite to the force experienced by object B. Now imagine golf club hitting a stationary ball. After collision, the speed of the ball is much greater than the speed of the swinging golf club. While the force appears to be unequal, it is the acceleration that is unequal. Take the equation F equals ma. Force is the same, but if mass is different, then acceleration will be different. Explosions. 1. Explosions of a stationary object. We make the following assumptions. Momentum before equals momentum after, provided that no external forces are acting. The momentum before is therefore 0. After the explosion, we assume no further acceleration, so the objects fly off at a constant velocity. For example, firing a cannon. The impulse of the explosion changes the momentum of the ball as it exists the cannon. The cannon experiences the same force, changing its momentum from 0 to a final value as it recoils. Due to the larger mass of the cannon, its recoil speed is lower than the ball. The forward momentum gained by the ball is equal to the backward momentum of the cannon. 2. Explosion of an object already in motion. Momentum is conserved because there are no external forces acting. The only forces acting are internal. During the explosion, the forces acting are equal and opposite, Newton's third law. Total energy is conserved, but the proportion of the types of energy before and after will be different. The object in motion already had kinetic energy before the explosion because it was moving, but there is likely to be more kinetic energy after the explosion. This is because the chemical energy from the explosion is converted into kinetic energy. Types of collisions. Elastic collisions. Kinetic energy is conserved. Inelastic collisions. Kinetic energy is not conserved.